Okay, so this is revision sheet number 3 for Algebra NCEA Level 2, and we are going to start off number 1 and work our way through. So the first question is asking us to expand. Now, to expand you need to get rid of all the brackets. The issue is that we have this 3 and we only have one set of brackets. So what does that 3 mean? That 3 means that there are 3 lots of this. So it's x minus 7, x minus 7, and then x minus 7. Okay, so 3 lots, that's what that 3 is talking about. And then to expand, what we do is we take, I often do the second ones first, or actually I just find the simplest ones first. So they're all the same, so I'll start with the second ones. So I'm going to leave the first bracket alone to start with, x minus 7, it's going to be exactly the same. And I'm going to minus times the first one by the first one, which is x squared. And I'm going to times the first one by the second one, which is going to be minus 7x in this case. And then I'm going to times the second one by the first one. Now note that this is a negative 7, just like that is a negative 7. So negative 7 times x is negative 7x. And then finally, negative 7 times negative 7. So negative 7 times negative 7 is positive 49. Okay, now I'm going to do exactly the same process, but multiplying the first bracket by the second bracket. So I'm going to go the first, actually no, what I'll do is I'll simplify this first. I look in here and I say, are there anything similar? There are no other x squareds, but there are 2 x's. There's an x there and there's an x there. This is an x squared, and this is just a number by itself. So I can't add those, but I can add these two in the middle. So I'll do an extra step of working, x minus 7, not changing that first bracket, squared, and it's going to be minus 7 is minus 14 when I add those together, plus 49. Okay, so now I'm going to do the same process that I did up here, down here. So I'm going to go the first one, multiply by the first one, and x times x squared is x cubed. Now I'm going to go the first one, multiply by the second one, first one multiplied by the second one, is x times negative 14x. Remember it's a negative 14x, and it'll be squared. Then the first one times the third one, x times 49 is positive 49x. A lot of students forget to put this x in for some reason. Make sure where it's an x times something, it's you are putting that x in. Then I'm going to do the second one, multiplied by the first one, it's a negative 7. So negative 7 times x squared is negative 7x squared. Then negative 7 times negative 14x. So they're both, it's a negative times a negative in this case, which means it's going to be a positive. So positive, and then, oh my goodness, 7 times 14, 7 times 10 is 70, 7 times 4 is 28, so I add the 70 and the 28 and I get 98. 98x, of course you could do that on your calculator. And then negative 7 times positive 49 is a very hard one, so I'll actually use my calculator for that. 7 times 49, 343, and it's a negative times a positive. It's a negative times a positive, it's a negative. Negative times a positive is a negative. So 7 times 49 is 343, and there's no x because there's no x. Now I need to go through and find my common values. There's an x cubed, there are no other x cubes. There's an x squared there and an x squared there, so I can add those together. And there's an x there and an x there, and the number by itself is all by, there's no other numbers, just by itself. So I need to go through x cubed, I can't change, there's no other x cubed. The green ones, the x squareds, the negative 14x squared and the negative 7x squared, I need to add those together, and that becomes negative 21x squared. I'm now going to add the x's together, 49 and 98. I add those on and I get 147. Note that they're both positive in this case. So 147x. And then finally, 3, 4, 3. And that there is my answer. Once I've got my answer, I'll put it in the box so the marker knows where it is. And we can move on to question number 2. Solve quadratic equations. It's very similar to factorising and then doing linear equations, kind of combining the two. The first thing I need to do is make it equal to 0. So I'm going to get rid of this 66. To get rid of that negative 66 is I just minus 66, and then I minus 66 here, and I can go 3x squared plus 27x, and now that minus 66. On this side, 66 minus 66 is, yes, it's 0. Beautiful, that's what I'm wanting. I'm wanting an equal 0. Now, once I'm to this step, I can start factorising. I look at this, and the first thing I ask myself is there a common factor? Very important that I do that first step. I could look at it and say, oh, it's a hard factorising one, and then go that times that, and do all those millions of steps. However, it's much easier if I just ask myself straight off the bat, is there a common factor? And in this case, there is. If I look at these three numbers, 3, 27 and 66, is there a number that goes into all three of them? There is. It is 3. Put that on the outside, my bracket, and go 3 times what gives me that? It's x squared. 3 times what gives me that? Plus 9x would give me 9 times 3, 9x times 3 would give me 27x, and this is a negative, so it'll be a negative here. 66 times what gives me, times 3 gives me 66, 22. So 22 times 3, forgive me, sorry, I mucked that up. 22 times 3 is 66. Okay, so I've taken 3 out of all of these ones here and put it outside, and that still equals 0. Don't forget that step. You can't get rid of this. If you lose the equals 0 and you're working somewhere, you'll get marked wrong. Okay. Now, I want to get rid of that 3, okay, and so to do that, there is an invisible times sign here. To get rid of it, I need to therefore divide by 3, and I'll divide that side by 3. They'll cancel out, and I'm left with, yes, I'm actually left with 0, because 0 divided by 3 is 0. So I've got x squared, 9x minus 22. It's one of those rare occasions in maths where if you do something to this side, it changes the look of this side. Like it used to be this and now it's this. But when you do it to this side, it doesn't change this side. It's quite nice. It makes it actually simpler. It's good. Okay, so now we need to just do normal factorising. I need to find numbers that add to that and times to that. Go through my normal process. 1 times what gives me 22 is 22. 2 times what gives me 22 is 11. 3, 4, 5, 6, 7, 8, 9, 10. None of them go into 22. So that's my process. I look for 2 which add to 9. It's those ones there. It's a positive 9, so in this case it would have to be a negative 2 and a positive 11 equals 9x, or it equals 9. I'll get rid of that 9. X, there's no x's involved. So I'm going to go x squared. Once I've got those two numbers, I can put them into my brackets, straight into my brackets. So x minus 2, and then x plus 11. Still equals 0. Now, final step, I need to say, remember, if these things here are multiplying, this is an invisible multiply sign, if these things are multiplying to 0, one of these brackets must equal 0, okay, or both of them, So we'll go x minus 2 equals 0, or x plus 11 equals 0, okay, then I'm going to go, if x minus 2 equals 0, I will add 2 to this side. To get rid of that, I'm trying to get to x equals. I'll add 2 to that side. And I'm left with x equals 2. Or, to get rid of that negative 11, I've got to minus 11 from this side. I've got to minus 11 from that side. So x will equal 11. Oh, sorry, negative 11. 0 minus 11 is negative 11. So, I can write over here, x equals negative 11. I'm going to write and or. If you wrote or, that's okay. Or 2. Okay, and I'm going to put that in a box. And I don't think you can quite see that. That's it there. Okay, x equals negative 11 and or 2. Okay. Question 3. We're going to factorise this equation here. So this is awesome. So the first one, I look at it and I'm like, oh, it's a hard factorising because it's got a number in front of it. But then I look at all the numbers and I ask myself, is there a common factor? And I go, yes, look, there is a common factor. If I look at those 3 numbers, then they can all be divided by 3. So that's excellent news because it means I can do similar to what I did up here, where I took the 3 out of the brackets here, where I took the 3 out of the bracket here, I was able to make it way simpler, okay? And that's because it has a common factor of 3. So it's similar to that. I'm going to do the same thing here. I'm going to take 3 out, okay? So 3x, 27x, and 30. I'm going to go 3 outside for a start, and then x squared plus 20, oh, no, it's not 27. 3 times what gives me 27? It will be 9x. 3 times what gives me negative 30? It'll be negative 10. Okay, now there's no equal 0. It's not like solving a quadratic. All I need to do now is get these into brackets, and I leave the 3 here. So the 3 stays here. Now what I'm trying to do, because now it's like a simple factorising one, I need to find numbers that add to that and times to that. So my process over here, 1 times 10 gives me 10, 2 times 5 gives me 10, 3, nothing, 4, nothing, 5, look at that, I'm back to 5s, so I don't need to even do that one. Okay. Which ones of those 2 pairs adds to 9? It will be that one there. It's the only combination that will work, because 2 and 5, no matter what the signs are, that would give me 7 or negative 3 or something along those lines. Okay, nothing goes to 9. Now one of them must be a negative in this case to get to 9, and in this case it would be a negative 1. Negative 1 and positive 10. So I'm going to take that and I'm going to create 2 brackets out of this using those 2 numbers. It's essentially like I'm pretending that 3 isn't there, okay? And I'm just trying to create 2 brackets. So it's x plus 10 and x minus 1. And that is it fully expanded, okay? It's, or factorised, sorry, that's it fully factorised. If you'd written this, you might not have taken the 3 out, and you had 3x plus 30 as one of your brackets, and x minus 1 as the other one. That is, so I'll put, this is my answer. That is correct, and you might get it marked right, okay? But you can factorise this one here more. You can factorise that one more by taking a 3 outside of it, okay? There's in other words, there's a common factor in the brackets. And we don't generally like that, okay? Solve exponential. So as soon as I see an exponential equation where the x is up here, it's up above the 2, I know I need to use logs, so I'm going to go log. My goodness, my computer didn't like that. Okay, I'm going to do that again. Log 1998 equals log 2x. All I've done is I've logged both sides because I know I need to do it to get that x. And this is why I need to bring that x down in front. And that's the only way I can do that is to get logs if it's been logged. So this side here will stay the same, log 1998. If you're listening, a big truck just drove by. I apologise about that. X log 2. I brought the x down in front. That's great. Now there's an invisible times sign here, like that. And so I can, I'm trying to get to, remember, in anything where it says solve, I'm trying to get to x equals something. You know, seeing solve, I'm thinking I've got to get to x equals. So I'm going to go x equals, oh, actually, I'll do an extra step of working for you. So to get rid of that log 2, I now divide by the log 2, okay, because it's timesing, and therefore I'm going to divide that by log 2. So x equals log 1998 over log 2, okay, and that is equal to, here you're going to have to use your calculator. Whenever you're solving for a log, you can use your calculator. Just make sure when you're putting it in that you are pressing the divide button, not the A, B, C thing, not the fraction one. You're using that one. Okay, log 1998 divided by log 2. And that gives me 10.96. It's really important that if you're going to round it, you tell us how many. So I say 2dp, which stands for 2 decimal places. Note I've got 2 decimal places. Just so you're aware, the next number in my number was a 4. If that was a 5, this would change to a 7, okay? But if it's anything less than 5, I don't change it, I don't round it up. Okay, so that's 10.96, and make sure it's right, I put a box around it. Okay, question number 5 is simplifying exponents. Okay, so I'm going to go. First thing I see is that it's got a negative 2/3 here. If it's got a negative exponent, I need to flip it upside down, but it's not attached to anything else, it's just attached to this p, so I'm just going to flip this upside down. And how do I flip something which doesn't even a fraction upside down? There's an invisible over 1 there, and so I'm going to flip it by putting it 1 over that thing there. So it's going to become 1 over p, and now it becomes a positive fraction, 2/3, still in brackets, and it's times by q 1/3, or sorry, 1/2. This isn't changed, and then that's all bracketed 3. So all I've done is I've flipped this upside down, this part here, to change that from a negative exponent to a positive. Okay. Now I'm going to times these things here. Whenever they're right beside each other, there's an invisible times sign, and whenever I times a fraction, I just times the top. So this part here times this part up here. This part here doesn't get times, okay? The reason for that is because there's an invisible over 1. So this is getting times by that, and this is getting times by that. Okay, so it's going to become q half, like that, over p 2/3, still to the power of 3. Okay. Final step. I now need to get rid of this 3 by, and this is the important thing, if there was a big number here, I would go this to the power of 3, and any exponents, but there aren't, so any exponents get timesed. So there's going to be times there, and because I'm timesing a whole number, remember this is like there's an invisible over 1 here as well, I'm going to times the top by the top, so that's going to get times, and the 1 is going to get times by the 2, and the 3 is going to get times by that, and the 3 is going to get times by the 1 down here. Okay, so it's going to become q, 3 times 1 is 3, and then 2 times 1 is just still over 2, and then p, 2 times 3 is, sorry, it's not 3, 2 times 3 is 6, I'll put that fraction back in, is 6, and then 3 times 1 is 3. And that is equal to, I can simplify it a little bit further, this can't change, this fraction is as simple as it'll get, q 3 over 2, however, this here, 6 divided by 3, I can make that slightly simpler, I can make it squared. Okay, and that is all you need to do, that's all you need to do. Okay, question number 6, again I see a negative exponent, I know I immediately need to flip it upside down, in this case it is a fraction, so I'm just going to flip the whole thing. So it's going to become 3p squared over 2mn, put that there like that, squared. Okay. Now the actual technical definition for flipping is called the reciprocal. So this is the reciprocal of this. It means it's upside down. So the reciprocal of this is this, and the reciprocal of this is this. Okay, they're just opposites of each other. Now I need to get rid of this squared. So again, I'm going to multiply these two numbers up here, this one here and this one here, but I'm going to go 3 squared. Okay, so it's going to become 3 squared. And for this one here, it's going to become 2 squared, big number is squared, and there's an invisible 1 there, so that's going to be times, and it's going to be 1 times again. Okay, so 3 squared is 9. The squareds are going to times each other, so p, 2 times 2 is 4, and then that's a 4. Very ugly 4, I'll do it again. It's a 4 there, it's not much better, but it's okay. 2 squared is 4, 2 squared, that's where I'm getting it from. And then m, 1 times 2 is 2, 1 times 2 is 2. Okay, and then I need to look at this and ask myself, can I simplify any further? Like, do the numbers have anything in common? No, they don't. And there are no p's on the bottom, there are no n's or m's on the top, so nothing else can be done. So that's it. The hardest part about that is this -2, and then potentially the expanding of the brackets. Okay, just so you're aware, actually, I'll just do that one just another way, just in case you've done it another way. This squared, remember, just means this bracket twice. So I could go, oh, whoops, sorry. I'll go back, hopefully. The computer will let me. Good. will. Okay, so if I just go back, delete that, and I say this squared here means this bracket times 2, so it's 3p squared over 2mn multiplied by 3p squared. I'll just shift the camera so you can see. 3p squared over 2mn, and then you can just multiply those things. So you can go this times this, so 3p squared times 3p squared, and that will give you 9p4, and then 2mn times 2mn is 4m squared n squared. Okay, doesn't really matter which way you get it, you get, as you can see, the same answer here and here. So I'll put a square box around that to tell my marker where it is, and I won't get rid of it, but normally you would get rid of all this over here if you were doing it that way, so the marker doesn't get confused. Moving over to equations and inequations, solving them. So I'm going to solve the first one by multiplying out the brackets first. I need to get it to x equals, so I need all my x's on one side. Okay, so it's going to be 5x plus 3, 3 times 3x plus 1. Okay, so I need to firstly expand this to be able to move the x's around. I'm going to go 3 times 2x once it's 5x plus 3, that's not changing. Then 3 times 2x is 6x, 3 times 1 is positive 3. Now I can move my 6x's around. Now I probably want to get the 5x, the x is over here, because if I minus the 6x over this side, that'll turn it to a negative, and I don't want that. But I could do it if I wanted to. And I'm going to take that one and move it over here instead. So getting rid of that 5x, I need to minus 5x. I'm going to minus, whatever you do to one side, you need to do to the other. So I'm going to minus 5x from this side as well. 5x minus 5x plus 5x is 0, so I'm left with 3 here. And 6x plus 3 minus 5x, 6x minus 5x is x plus 3. That's 6x minus 5x is x, and then the 3 is still there. Now I'm trying to get to x equals, remember, so I'm going to get rid of that 3. To do that, I minus 3, and I minus 3, so 3 minus 3 is 0, okay, and x, look at that, is actually equal to 0. Put a box around it, and I'm done. Next one, an equation. I'm essentially trying to get to x this thing, okay, or x this thing. It doesn't matter, but well, it does matter, but it depends on what the question is. Depending on, we'll define what I'm going to get. But again, it's similar to the equation in that I'm trying to get to this, but there's no equal sign. There's this thing instead, a greater than or less than sign. But the process is pretty much exactly the same. So first thing I look at when I see this line here is I'm trying to get rid of the fractions. I don't like fractions when I'm solving. So to get rid of a fraction, this is currently dividing, this 3x plus 5 is being divided by this 4. So to get rid of the 4, I multiply by 4. And this whole thing is going to be multiplied by 4. And then I need to multiply this by 4. And again, this whole thing is going to be multiplied by 4. So that is going to cancel out, because if I times that by 4 and then divide it by 4, it's just going to be 1. So that's why I've done that, times it by 4. And then this thing, less than sign, and then I'm going to go 4 times that. Oh, sorry, I'll go back to black. So 4, and then 6x. I'm not going to expand it out yet, and it's still over 8. Now I've still got a fraction in my equation, so I want to get rid of that. Exactly the same process. I'm going to times it now by 8. Okay, I'm going to times this by 8. Okay, and then I'm going to go, okay, so 8 times, it's 8 times all of this. It's not just 8 times 3x, it's 8 times everything on this side. So I'll just put it outside the brackets for now. 3x plus 5 less than, and then the 8 will cancel out, which is great, and so I'm left with 4, 6x minus 1. Now I just need to expand it, so I'm going to go that times that, that's 24x, then that times that, and that's plus 40, less than, and then 4 times 6x is 24x, and then 4 times -1 is -4. Okay, now I can, oh dear, okay, I can see already that this is a reject one. I can see that there's a 24 here and a 24 here. I'm going to try and get x's all on one side. So to do that, I'm going to minus 24 here, 24x, and then I'm going to minus 24x from this side. However, if I minus 24x from that side, I'm left with 0x, so I'm just left with 40, and I'm left with 0, and then those things there will also give me 0, so I'm left with -4. And this makes no sense. 40 is less than -4, reject. Every now and then they'll give you one of these questions where the answer doesn't make sense, so you just kind of have to reject the equation, okay? It's very unlikely they'll give it to you. Normally you're looking for something with x's left and as a less than or greater than something, okay? Simplify rational expressions. So I'm going to simplify this by going x squared plus 7x plus 12 is equal to, I need to factorise this and factorise that, and then I can cancel things out. So I'm going to go what numbers to factorise. I'm going to go what numbers add to that and times to that. So over here, 1 times what gives me 12 is 12. 1 times what gives me 12 is 2 and 6. 3 times 4. 4 times, oh look, I've already got it, so I don't need to do the 4 times. Which ones of these add to 7? It is these two here, and they must both be positive to do that. Okay, so it's going to be x plus 4, plus 3, sorry, and then x plus 4. All over, we've got to factorise again, adding to that number there, times into that number there. So we're going to go x, the ones that add times to -12 is 1 and 12, 2 and 6, and 3 and 4. Which of those adds to -1? Again, it's going to be these ones, but the signs are going to have to be different. In this case, it will be -4 and +3. Those are the only ones that will add to -1 out of all those combinations there. So I can now write under here, x plus 3, x minus 4, and I can kind of see, when I'm doing these, I'm looking for ones that are similar. So if I've got an x plus 3 on the top and an x plus 4 on the top, I'm really looking for ones with at least one of those things. And at the moment, I can tell I've done it right because I've got an x plus 3 there and an x plus 3 there. So I can cancel. These ones here, even though they're the same numbers and letters, because they've got a different sign, I can't cancel them. So I'm left with x plus 4, x minus 4, and that there is my answer, so I'll put a box around it. When you're doing it, make sure you don't do what I just did and sort of cross out a little bit of your answer. Make sure it's nice and big so that the marker can see your work. Okay. This one here, times and fractions. All you have to do is you have to times along the top and you have to times along the bottom. They're nice and easy times and fractions. So AC times B squared is equal to A. Write it in alphabetical order. It's useful. So AB squared C. And that's going to be all over b times c cubed, so bc cubed. Now I need to simplify that a little bit further. I can't do anything about the a's because there's no a's in the bottom, but there is a b here and it's an invisible 1, so I need to go 2 minus 1 for that one there. So we'll start doing my answer. A, nothing happens. B, 2 minus 1 is b up the top. It's b1, but we'll just leave the 1 out. And then I've got a C, and there's also an invisible 1 above this C, and so it's 3 minus 1. You always go the bigger one minus the smaller one, no matter where the bigger one is. And so that becomes C, 3 minus 1 is 2, and you put it where the bigger one is, okay? And so that there is my answer. Nice and quick, that one. This one here, minusing. Minusing is the same as plussing. I need to do this thing called cross and drop, like this. Okay, and I'm going to times along those arrows. I'm going to times along those arrows. So, first one is x times x4, so I'll just put that way over here, x times x4. I won't actually do the multiplication yet. And then I'm going to go x squared times x2, x squared times x plus 2, and that's all over x times x squared. I will do that one, that's x cubed. Okay, I'll do that 3 a bit better though. So I'll just do that overline and then it's cubed. Okay, the only thing else I need to put is whatever is there. If it's a minus or a plus, the only difference between those ones is what goes here, and for us it's a minus. So, and the minus comes from there, that's why that's there. Let's circle that so you can see that minus goes there. Okay, so x squared, I'm going to expand these out now. So we're going to go x squared times x is x cubed. X squared times 2 is positive 2x squared. I'm now going to go, this is a negative x, so it's negative x times x is negative x squared. I'm going to go negative x times negative 4. It's a negative times a negative. Negative times a negative. So that is positive 4x. That's all over, still x cubed. Now normally I could just leave it there. However, I can see already that there is a common factor amongst all these ones here, and that common factor is going to allow me to cancel some things here. The common factor being they all have an x in them. There's no common number, but they all have a common letter. So it's a good idea, in fact it's a mandatory idea, you have to do it. I take the x outside, they've all got x, and I'm going to go x cubed minus, oh sorry, taking the x out, so I need to now go x times what gives me x cubed. It's x squared. X times what gives me positive 2x squared is 2x. X times what gives me negative x squared is negative x. X times what gives me positive 4x, it's positive 4. And that's all over x cubed. I can now cancel, there's an invisible 1 here. And there's a 3 there, so I can go 3 minus 1. And I will just move down a little bit. So I'm going to go x squared. And actually I can add these two here, see how they've both got x's? I'll just add them together in this one. 2x minus x is just x, so plus x. And then I've still got that plus 4. And this x cubed is turned into an x squared. Now there is no common factor here, so therefore I can't cancel anything, and so I know that I am done. Okay, so I'll stop them. I will now move to question 12, almost done. This one here, it's a log question. I need to rearrange it first to be able to solve it. It's solving these two, so I'm going to use my calculator. So I'm going to have to do the rearrangement, and the rearrangement always looks like this. The 3 stays exactly where it is. The 9 goes up to there, and the x goes up to there. And you just need to remember that. There's no other way to do it. You just need to remember it. The 3 stays there it is, the 9 goes up, and so the 3 stays where it is. If you can remember that, everything else goes up. Everything else goes up. The 9 goes up to normal, and the x goes up to an exponent. Okay. Once I've got to this, I need to go 3 to the power of what gives me, well, 9 to the power of what gives me 3. I don't actually know that, so I'm going to have to, if I knew it, I could just write x equals this, but I don't know it. So I'm going to log both sides to get that x down, okay, similar to a question we did earlier. So log 3, I'm going to log both sides, log 9x. Now I can bring that x down in front. Log 3 is now going to be equal to x log 9. And there's a small multiplication sign there. So to get rid of that log 9, because I'm trying to get to x equals, I'm solving, trying to get to x equals, I divide by log 9. I divide by log 9. And so x will equal, these things here cancel out, x equals log 3 divided by log 9. I'll go to my calculator. Log 3 divided by log 9 is equal to a half. It's actually equal to 0.5, but I'm going to write a half. Put a square around it, and I'm done. Move to the next one. Again, this is a solving one. It's still part of the solving logs up here. So to solve these logs, I need to figure out log x equals 4 log 5. I'm trying to get to remember x equals, I get to x equals something, so I need the x by itself. Therefore I need to get rid of that log. How do I get rid of that log? Well, to get rid of a log I need to get rid of a log here as well. So if that's the case, to be able to get rid of the log here, I need to put that 4 up there. That's going to be my first step. So I'm going to put the 4 up there so I can get rid of the log. So my first step will look like this. Log x equals log 5 to the power of 4. And then I'll just simplify that. So log x equals log 5 to the power of 4 is 20. No, it's not. It's 5 times 4. 5 times 5 is 25, times 5 is 125, times 5 is 625. And so now I can get rid of the logs. Because they're both logged, I can unlog them. Just like I logged both of these ones up here, from that to this, I can unlog things. So I can, as long as I'm taking one away from one side, I can take one away from the other. Okay? So x equals 625 once I've taken away those logs, and so I'm done. That is me done. Final one, right is the log of a single number. Another way you could read this is the word simplify. That means you are not going to use your calculator. Okay, you are not writing, you're not going to use your calculator, you're writing as a log of a single number, so your answer should look something like this, log question mark, whatever that number goes there. Okay, don't give me just a number, I need to log something. So to do that, I need to combine all these things together, and to do that, I need to put all these numbers up here. Okay, things about logs. So this is log 4, 3 plus log 3 to the power of 2 minus log 2 to the power of 3. Now I can go 4 to the power of 3, what's that? 4 times 4 is 16, times 4 is 64, plus log 3 times 3 is 9, minus log 2 times 2 to the power of 2 times 2 is log 8. Now I'm trying to combine these. To combine ones where you add them, you need to times the numbers. You're going to so there's a little sort of times sign going on. So it's going to be log 64 times 9 minus log 8. Okay, so that'll be log 64 times 9. I'll need to do on my calculator. 576 minus log 8. When I'm trying to combine logs, the minus sign is similar to a divide. So I'm going to go log 576 over 8. And that is going to be equal to, again I have to do that on my calculator, 72. And that there is my answer, because I'm just trying to get to a log of a single number. And that ends revision sheet number 3.